In the 1970s, it was an acceptable practice to use the safety ground as a neutral in three-way switch circuits. At that time, the National Electrical Code, or NEC, did not explicitly prohibit this method. The main risk of leaving three-way switches wired with the safety ground as a neutral is electrical shock hazard. The safety ground wire is intended to carry any fault current to ground, protecting people from electrical shocks. By using it as a neutral, this protection is compromised. If a fault occurs in the circuit, current could flow through the safety ground, creating a dangerous voltage potential in the light fixture or other components. Today, the NEC requires that three-way switch circuits be wired with a dedicated neutral conductor separate from the safety ground. This is to ensure that the safety ground remains intact and can perform its intended function of protecting against electrical shocks. For the safety of your home and occupants, it is highly recommended that you rewire these three-way switches to use a dedicated neutral conductor. This will bring the electrical system up to modern code standards and eliminate the risk of electrical shock hazard. Understanding electrical wiring practices, especially in older homes, is crucial for ensuring safety and compliance with current electrical codes. In the context of three-way switches, the role of the neutral and ground wires is paramount in preventing electrical hazards. Let's delve deeper into the specifics of three-way switch wiring, the evolution of electrical codes, and the potential dangers of using the ground wire as a neutral conductor. Firstly, a three-way switch allows you to control a light fixture from two different locations. This is commonly used in hallways, stairwells, and large rooms where you might want to turn a light on or off from either end. The wiring configuration involves two switches, a power source, the light fixture, and typically at least three wires running between the switches, excluding the ground wire. Secondly, the traditional method of wiring three-way switches involves a hot wire from the power source to the first switch, two traveler wires running between the two switches, a switched hot wire from the second switch to the light fixture, and a neutral wire that completes the circuit back to the power source. The ground wire is typically connected to the metal boxes of the switches and the light fixture for safety. Now let's discuss the historical context. In older electrical installations, it was not uncommon to find practices that are no longer considered safe or compliant with modern codes. The use of the ground wire as a neutral was one such practice. While it might have been acceptable or even common in the past, it introduces significant safety risks. The ground wire is intended to provide a path for fault current to return to the source in the event of a short circuit or other electrical fault. This allows the circuit breaker to trip and disconnect the power, preventing electrical shock or fire. When the ground wire is used as a neutral, it carries current continuously as part of the normal circuit operation. This compromises its ability to function as a safety ground. In the event of a fault, the ground wire may not be able to effectively carry the fault current, increasing the risk of electrical shock. Furthermore, using the ground wire as a neutral can create a voltage potential on metal parts of the electrical system, such as switch boxes and light fixtures. This can result in a dangerous shock hazard if someone comes into contact with these parts. The National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect new technologies and safety practices. Modern versions of the NEC explicitly prohibit the use of the ground wire as a neutral in most situations. The code requires that the neutral wire be a separate, insulated conductor that is dedicated to carrying the return current from the load. If you encounter a situation where the ground wire is being used as a neutral, it is highly recommended that you correct the wiring to comply with modern code requirements. This typically involves running a new neutral wire to the switches and light fixture and ensuring that the ground wire is properly connected to the grounding system. It is important to note that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about how to proceed. A professional electrician can assess the wiring in your home, identify any potential hazards, and make the necessary repairs to ensure that your electrical system is safe and compliant with current codes. In addition to the safety risks, using the ground wire as a neutral can also cause other problems such as electrical noise and interference. This can affect the performance of sensitive electronic equipment, such as computers and audio equipment. By using a dedicated neutral wire, you can minimize these problems and ensure that your electrical system operates properly. When working with electrical wiring, it is essential to follow all safety precautions. Always turn off the power to the circuit before working on any wires. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. They have the knowledge, skills, and experience to perform electrical work safely and correctly. In summary, while using the ground wire as a neutral and three-way switch circuits may have been an acceptable practice in the past, it is no longer considered safe or compliant with modern electrical codes. The ground wire is intended to provide a path for fault current to return to the source in the event of an electrical fault. Using it as a neutral compromises its ability to function as a safety ground and can create a dangerous shock hazard. It is highly recommended that you correct any wiring that uses the ground wire as a neutral and ensure that your electrical system complies with current code requirements. This will help to protect you and your family from electrical shock and fire. Remember, electrical safety is paramount. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any concerns. Modern electrical systems rely on several key components to ensure safe and efficient operation. Firstly, overcurrent protection devices like circuit breakers and fuses are designed to interrupt the flow of electricity when the current exceeds a safe level, preventing damage to wiring and equipment, and reducing the risk of fire. Secondly, grounding systems provide a low impedance path for fault current to return to the source, allowing overcurrent protection devices to trip quickly and clear the fault. Thirdly, ground fault circuit interrupters, or DFCIs, are designed to detect even small amounts of leakage current to ground and quickly interrupt the circuit, protecting people from electrical shock. These devices are commonly used in bathrooms, kitchens, and other areas where there is a risk of water exposure. Electrical codes and standards are constantly evolving to reflect new technologies and safety practices. It is important to stay up to date on the latest code requirements to ensure that your electrical system is safe and compliant. In addition to the NEC, there are other organizations that develop electrical standards, such as the Institute of Electrical and Electronics Engineers, or IEE, and Underwriters Laboratories, or ALL. These organizations develop standards for electrical equipment and components, ensuring that they meet certain safety and performance requirements. When selecting electrical equipment and components, it is important to choose products that are listed or certified by a recognized testing laboratory, such as UL. This indicates that the product has been tested and meets certain safety standards. Electrical wiring comes in a variety of types and sizes, each designed for specific applications. The most common type of wiring used in residential construction is non-metallic sheath cable, also known as NM cable or Romex. This type of cable consists of two or more insulated conductors, plus a ground wire, encased in a plastic sheath. The size of the wiring is determined by the amount of current it is designed to carry. Wiring sizes are typically expressed in terms of American wire gauge, or AWG. The smaller the AWG number, the larger the wire. For example, 12 AWG wire is larger than 14 AWG wire. The NEC specifies the minimum wire size for various applications based on the ampacity or current carrying capacity of the wire. It is important to use the correct wire size for the application to prevent overheating and potential fire hazards. Electrical boxes are used to enclose wiring connections and provide a safer and convenient way to mount electrical devices, such as switches and receptacles. Electrical boxes come in a variety of shapes and sizes, and are typically made of metal or plastic. Metal boxes must be grounded to provide a path for fault current to return to the source. Plastic boxes do not need to be grounded, but they must be used with non-metallic sheath cable. Wiring connections should always be made inside electrical boxes, using approved connectors. Wire nuts are commonly used to connect wires together. These are plastic caps that screw onto the ends of the wires, providing a secure and insulated connection. It is important to use the correct size wire nut for the number and size of wires being connected. Electrical tape is used to insulate wiring connections and protect them from moisture and corrosion. Electrical tape should be applied in a neat and overlapping manner, ensuring that all exposed conductors are completely covered. When working with electrical wiring, it is important to follow all safety precautions. Always turn off the power to the circuit before working on any wires. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. In addition to the topics already covered, it's crucial to understand specific code requirements for three-way switch installations. The NEC, in its current form, provides detailed guidelines to ensure the safety and functionality of these circuits. Firstly, the NEC mandates the use of a neutral conductor in switch loops for three-way and four-way switch installations. This requirement, introduced in recent code cycles, aims to reduce the risk of voltage being present on the switch enclosure even when the switch is in the off position. Secondly, the code specifies that the neutral conductor must be run to each switch location, allowing for the future installation of smart switches or other devices that require a neutral connection. This is often referred to as a switch loop neutral. Thirdly, the NEC requires that all wiring connections be made inside approved electrical boxes. These boxes provide a safe enclosure for the wiring and protect against accidental contact with live conductors. The boxes must be properly grounded to provide a path for fault current to return to the source. The NEC also addresses the use of different wiring methods for three-way switch installations. Non-metallic sheath cable, or NM cable, is commonly used in residential construction. However, other wiring methods, such as conduit, may be required in certain applications such as commercial buildings or areas where the wiring is exposed to physical damage. When running wiring through walls or ceilings, it is important to follow the NEC guidelines for protecting the wiring from damage. The code specifies the minimum distance that wiring must be kept from the edge of framing members, and requires the use of nail plates to protect wiring from being penetrated by nails or screws. It's important to be aware of voltage drop in electrical circuits. Voltage drop occurs when the voltage at the load is less than the voltage at the source. This can be caused by long wire runs, undersized wiring, or excessive current draw. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for various applications. Excessive voltage drop can cause equipment to malfunction or overheat. Furthermore, consider arc fault circuit interrupters, or RFCs. RFCs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when there is a loose connection, damaged insulation, or other electrical fault. RFCs are required in many areas of the home, such as bedrooms, to protect against arc fault hazards. The NEC also addresses the use of surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges which can be caused by lightning strikes or other electrical disturbances. SPD are typically installed at the service entrance of a building, but can also be installed at individual circuits or equipment. When working with electrical wiring, it is important to follow all manufacturers' instructions for the equipment and components being used. This includes instructions for wiring connections, mounting hardware, and other installation details. Failure to follow manufacturers' instructions can void the warranty and create a safety hazard. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical wiring or safety. Consider, as well, the impact of electrical modifications on home insurance. Improper electrical work can not only create safety hazards but also affect your home insurance coverage. Insurance companies may deny claims if they find that electrical work was not performed by a qualified electrician or that it does not meet current code requirements. It is essential to document all electrical work performed in your home, including permits, inspections, and receipts from qualified electricians. This documentation can be helpful in the event of an insurance claim. Smart homes and the future of electrical systems is also an important consideration. Smart home technology is becoming increasingly popular, with devices such as smart switches, smart thermostats, and smart lighting systems. These devices can be controlled remotely using a smartphone or other device. The NEC is evolving to address the unique requirements of smart home technology, such as the need for reliable communication networks and secure access to electrical systems. As smart home technology becomes more prevalent, it is important to ensure that these systems are installed and maintained by qualified professionals. This will help to ensure the safety and security of your home and family.